All right, so welcome back to your favorite inorganic tutor YouTube channel once again. Today is another episode, and this episode is going to be so snappy, it's going to be crazy because we are going to look at how we can use the Gauss Jordan method of elimination to solve an inverse of a 3 by 3 matrix, right? Using a Gauss Jordan to solve a matrix is so um, simple, but it looks complex for some people. And right here, I'm going to make it so easy and so swift for people to understand. Thank you. So now let's go look at how we can solve this, right? So this right here, we have to first, what we have to do is create um, the augmented matrix, right? We have to create the augmented matrix A, right? So we have to augment this matrix with an identity matrix with the same size as this. So this is a 3 by 3. So we create an augmented matrix with the same size as the identity matrix. And we know that an identity matrix, which is I3, has this element in the 0, 0, 1. This right here. So we are going to augment this with this, right? Now let's go. So A augmented with the identity matrix should be equal to 2, 1, 1, 1, 3, 2, 1, 1, 3. Then we augment it. We are augmenting it with the identity matrix, which is going to be 1, 0, 0, 0, 1, 0, 0, 0, 1. Right, so this is the augmented matrix of a 3 by 3 identity matrix together with the matrix A. So what next? What we have to do is that we have to check the first element on the first row. We have to make sure that it is a leading one. And this right here, it is not. So we have to make sure that this 2 right here is 1. The reason behind it is that this right here is on the diagonal, the main diagonal. So we have to make sure that before we can stand on a row to work, we have to make sure that the leading element is 1 because all the diagonals must be 1. So let's go. We have to divide row 1 by 2. So when we do that, we're going to have 1 right here, half, half, right? Then we are going to have augmented with half, 0, 0. Then maintain the second and the third row. Right. So now we have our leading element to be 1. So we can go ahead and eliminate the lower, let's start with the upper triangular matrix. So we eliminate this element, come here, come here. I've already taught you the secret in the Gauss Jordan. We don't go in any other direction than moving from the first element in the second row, then you come down to the first element in the third row before you go to the second element in the third row. So now we have to make sure that the first element of the first row is equal to 1. That is what we have right here. So here, what we have to do next is that we eliminate this first element of the second row. So what we do, we say that row 2 should be equal to row 2 minus row 1. Row 2 should be equal to row 2 minus row 1, right? We want to eliminate this right here. So this minus this will give us 0. So we're gonna have we maintain the first row, right here. So 1 minus 1, and that is 0. 3 minus half is what? 3 minus half, and that is 5 on 2, right? And then we go ahead, 2 minus half, 2 minus 1 over 2, and that is 3 on 2. 0 minus half, and that is negative half. When we come here, 1 minus 0, and that remains 1. And then 0 minus 0 is 0. So we come down to maintain our row 3. Right. Very, very simple. So now we have eliminated the first element on the second row. We come down to the first element on the third row. So what do? We use row 1 to do that work. So we say that row 3 should be equal to row 3 minus row 1, because 1 minus 1 is going to give us 0. So right here, we're going to have maintain the first row, right? Then we maintain the second row as well. Right? So now we are interested in the first element on the third row. So that is 1 minus 1, and that is 0. Then we have 1 minus half, and that is half, right here. Now we go ahead to the next element, 3 minus half. 3 minus half, and that is 5 on 2. Then we have 0 minus half, and that is minus half. Then we come 0 minus 0, then we have 0 right here. Then we have 1 minus 0, and that is 1 right there. So now we have to move to the second element on the third row. So now we have to now move to the second row to eliminate the last element that we are eliminating on the third row, right? So we are making the second element of row 2 equal to 1, because we said before you stand on a row to work on, make sure that the leading element is 1, right? So this right here is going to be 1 right here. So what do? We say that row 2 should be equal to 5, should be equal to 2 on 5 row 2. So we multiply row 2 by 2 on 5, and that we are going to have, let's maintain the first row, right here. So when we do that here, we're going to have 1, then 2 on 5 times 3 on 2, right? 3 on 5 times 3 on 2, right? And that is 3 on 5. 2 on 5 times 3 on 2, and that is 3 on 5, right? And then we come here, negative 1 over 2 times 2 over 5, right? And that is negative 1 on 5. Then 1 times 2 on 5, and that is 2 on 5. Then 0 times 2 on 5, and it's still 0. Then we maintain the third row. 0, 1. Now, we have made the leading element on the second row 1, right? So now we are coming to eliminate this half. So what we do, we have to say that row 3 should be equal to row 3 minus half row 2, right? When you take half of this, it means that half minus half is going to give us 0 right here. So this right here, let's maintain our first row, half 0, 0. Now 0 0 minus 0 right here is 0. So we maintain the second row as well. So we are working on the third row, right? So we say 0 minus half of 0, and that is still 0. Half minus half times 1, and that is 0 right here. Then 5 on 2 minus half times 3 on 5. And that is 11 over 5, right? Now we move to this right here. Half, negative half minus half times negative 1 over 5. And that is negative 2 on 5. Then 0 minus half times 2 over 5. And that is negative 1 over 5. Then 1 minus 0 is still 1. Very, very simple. When you follow the order, it's so simple for you to eliminate the elements. Now, we are done with the upper triangular matrix. Now we move on to the lower triangular matrix. So we start from here, right? So that we are going to say that let's move up. So we are going to say that row 1 should be equal to row 1 minus, we are interested in eliminating this, right? So we are using row 2 to do that. So row 1 should be equal to half row 2, right? So half row 2. You know, when you take half minus half is going to give us 0 right here. That is why we said half minus half row 2. So simple. So right here, we're going to have 1 right here, then half minus half, 0, then half minus 3 on 5 times minus half, right? Half times half minus half into 3 on 5, right? And that is 1 on 5. 1 on 5. Then the next one is going to be half minus 0 times half, and that is still 0. Half minus half times 2 on 5, right? And that is 3 on 5. 3 on 5. right? And then we go to 0 minus half times 2 on 5, and that is negative 1 on 5, negative 1 on 5. And then the last one is going to be 0 minus half times 0, and that is 0. So we maintain our second and third row, 0, 1, 3 on 5, negative 1 on 5, 2 on 5, 0, 0, 0, 11 on 5, negative 2 on 5, negative 1 on 5, and 1. So now we have dealt with the second element on the first row. So we move down to the third element on the first row. And that we are going to say that R3 should be equal to 5 on 11 R3, because we have to make sure that this right here is 1 before we can use this rule to eliminate this element right here. So we say that R3 is equal to 5 on 11 R3. So it means that we are multiplying R3 by 5 on 11. So we're going to have 1, 0, 1 on 5, 3 on 5, negative 1 on 5, 0. Then 0, 1, 3 on 5, negative 1 on 5, 2 on 5, 0. Then when we multiply through by that 0, 0, then we are going to have 1 right here. Now we're going to have, when we multiply this negative 2 over 5 by 5 on 11, then with that we are going to have negative 2 on 11, negative 2 on 11. Then when you multiply negative 1 on 5 by 5 on 11, you're going to have negative 1 on 11. Then when you multiply 1 by 5 on 11, you're going to have 5 on 11 right here. So now we can go ahead and use row 3 to eliminate this 1 on 5 right here. So we say that row 3 should be equal to, row 3 should be equal to, we want to eliminate the third element on the first row. So we say that row 1 should be equal to row 1 minus, guess what is going to be? 1 on 5 row 3. 1 on 5 row 3. Because 1 times 1 on 5 is 1 on 5 minus 1 on 5 is 0. So right here, let's come up here. So we maintain the, so right here is going to be still 1, 0, then the outside it goes to 0, then 3 on 5 minus minus 2 on 5, right? This right here minus 2 on 5 times 1 over 5, and that is going to give us 7 on 11, 7 on 11, 7 on 11. Then the second one is going to be minus 1 on 5 times minus 1 over 11 times what? Right here is going to be minus 1 on 5 minus 1 on 11 times 1 on 5, right? And that is going to be minus 2 on 11, right? And the last one right here is going to be 0 minus 1 on 5 times 5 on 11, right? And that is going to be negative 1 on 11. So we are done with the first row. So yes, let's maintain this right here. maintain this right here. So we have 0, 0, 1, and then negative 2 on 11, negative 1 on 11, and 5 on 11. So this right here is left this element alone to be eliminated so that we get the identity matrix on the left hand side. So this one can be our inverse of the 3 by 3 matrix. So the last one, what are we going to use? We can say that root 2 should be equal to root 2 minus 3 on 5. So that is going to be root 2 should be equal to root 2 minus 3 on 5 root 2. 3 on 5 root 3. All right, so that is going to be you are maintaining the first row right there. 7 on 11, negative 2 on 11, negative 1 on 11, and then we consider the row 2, and that is going to be, this part is going to remain 0, 1, and this part is going to 0 because 3 on 5 minus 3 on 5 times 1, and that is going to give us 0 right here. Very, very simple. Now we move to minus 1 over 5 minus 3 on 5 times negative 2 on 11, right? And that is going to give us 5. That is going to give us minus 1 over 11. Minus 1 over 11. And then when you move up here, 2 on 5 minus 3 on 5 times what? Negative 1 on 11, right? And that is going to give us 5 on 11, right? And then when we move up here, 0 minus 3 on 5 times 5 on 11, and that is going to give us minus 3 on 11. Minus 3 on 11. Now we maintain our last row, which is the third row, which is 0, 0, 1, then minus 2 on 11, minus 1 on 11, then 5 on 11. So this right here is the inverse of the matrix, and this is the identity matrix form. So let me write it up here for you. So this right here, 1, 0, 0, right here, 7 on 11, negative 2 on 11, negative 1 on 11, 0, 1, 0, negative 1 on 11, 5 on 11, negative 1 on 11, and then the last part is going to be 0, 0, 1, then negative 2 on 11, negative 1 on 11, and then 5 on 11. So this right here, this is the identity matrix, and then this is the inverse of A. So the left hand side is the identity matrix formed, and then the right hand side, the result over there, is the inverse of the matrix using the Gauss Jordan. I know this, you really appreciated it. So simple. I made the thing so simple. You know, matrix respect order. So whenever you are working on matrix, especially when you are using a Gauss Jordan, you have to make sure that you respect order. Don't move from third row to any other row just like that. Make sure that you move in order. Always make sure that you follow this principle. A, B, C, D, E, F, J, H, I, right? When you try to eliminate, make sure that you respect this order. You know that if we are interested in eliminating this, then we will start from here, but we want to eliminate this element, this upper triangular, right? So we have to start from here, eliminate this first element, but before you stand here to use this to eliminate, make sure that this element right here is 1. Then you can use it to eliminate this. Then you come down, eliminate this. Then you move here, eliminate that. Then the lower triangular, that one too, you start from here, move here, then you come here. That is very simple. So always move in this direction, then move here, then you come down. And then always make sure that before you stand on a matrix or you stand on a row to eliminate an element, make sure that the leading element is 1, because we are making sure that this diagonal is identity, or is that diagonal is ones, because the main diagonal must be 1, because we are working towards something, right? So this right here, whenever you want to stand on something, or right here, to make sure that you eliminate this, make sure that the leading element is 1. And this right here, when you want to stand on this to eliminate this, make sure that the lead element right here is 1. And this right here must be 1 right here. So very, very simple. Follow the principle and nothing will be difficult for you. Thank you very much. Please don't forget to press on the notification bell down there, and then I'll give you more updates. Thank you very much. Bye bye.